All right, so this video is for help on the topic simplify expressions. What exactly does it mean to simplify an expression? Well, there's lots of things that we could do to simplify expressions, but basically it means to write the expression as easily as possible, to combine together what we can combine together and write it with as few terms as we can. Some things that you have to do to simplify expressions are to factor expressions. And that's what's going on in this first problem. It wants us to factor an expression completely, to break it up into all its small parts. Because if we had this expression and another one, maybe if we broke it up into all its small parts, we could see some things that we could combine together and simplify the entire expression. So let's factor this expression. Well, what does it mean to factor an expression? Let's do the opposite of factoring. Let's distribute. If I had an expression and it simply just said 3 times x plus 5, if I told you to expand or to distribute, this is what you would do. You would say 3 times x is 3x, and you would say 3 times 5 is 15. So you have 3x plus 15. 3x plus 15 is the expanded version of 3 times x plus 5. So these two expressions are worth the exact same amount, but this one is expanded. Well, if I gave you an expanded expression like 3x plus 15, say something like 4x plus 20, I might ask you to factor it. And all that is going from the expanded version back to the one we had a second ago. This is the factored version. So what does each of these terms divide by? 4x divides by 4, and so is 20. So I will take the 4 out and then write in parentheses what I would multiply 4 by to get each of the previous terms. So 4 times what is 4x? 4 times x is 4x. So I write an x right there. And then it says plus, and this is a positive 4 and a positive 20, so everything's going to stay positive right now. 4 times what is 20? Well, 4 times 5 is 20. So if I asked you to factor 4x plus 20, I would ask you to write 4 and x plus 5. One of the factors of 4x plus 20 is 4, and the other factor is x plus 5. If I multiply those two things together, I'd get back to 4x plus 20. So that's how you factor an expression. But these are very easy expressions to factor. What if it was a bit more complicated? Well, sometimes you have something like this. Let's say you had a binomial like x plus 5, which is called a binomial because it's got two terms. Let's say you had a binomial like 2x plus 3, and you wanted to multiply it by another binomial like 3x plus 4. If I ask you to multiply this binomial by this one, it's not too different from the expanding we just did a moment ago. Earlier, when I said to multiply 3 by x plus 5, you just did 3 times x and 3 times 5, and then put them together, and that was it. Well, this is very similar. If I want 2x plus 3 times 3x plus 4, first I have to do 2x times 3x, and then 2x times 4. But after that, I also have to do 3 times 3x and 3 times 4. So basically, multiply each term in the first binomial by each term in the second binomial. So let's do that. What is 2x times 3x? Well, 2x times 3x, 2 times 3 is 6, and x times x is x squared. So 2x times 3x is 6x squared. Now, if you're not exactly sure why, let's just remember what 2x and 3x, what they mean. 2x means 2 times x, and 3x means 3 times x. So if I want to multiply 2x by 3x, I have 2 times x times 3 times x. So really, all you are multiplying together is 4 different things. 2, x, 3, and another x. Well, if you're multiplying, does it matter what order you multiply things? No. 2 times 3, I could put those first, so I could say 2 times 3, and then times x. It's all the exact same stuff, but in a different order. And in multiplication, the order doesn't matter. Now I could say 2 times 3 is 6, and x times x I would write as x squared. So if I have 6 times x squared, I just write it 6x squared, the same as I would write 2 times x is simply 2x. So anyway, 2x times 3x is 6x squared. Next, I have to do 2x times 4, which is 8x, so I will add 8x. And then I have to do 3 times 3x, which is 9x, so I'll add 9x. And then lastly, I have 3 times 4, so I'll add 3 times 4, which is 12. So now I've multiplied this binomial by this binomial, and I have this whole thing. Now you might notice that 8x and 9x can be combined together. 6x squared plus 8x's plus 9x's, well, that's just plus 17x's. So I can say plus 17x plus 12. So if I asked you to expand by multiplying this binomial times this one, you would get this trinomial, which is 6x squared plus 17x plus 12. What does that have to do with factoring? Well, just like here, if I could expand 3 times x plus 5 to make 3x plus 15, factoring would be going backwards. It would be turning 3x plus 15 into 3 times x plus 5. And factoring 4x plus 20 means turning 4x plus 20 into 4 times x plus 5. Those were very easy because you could see what 4x and 20 have in common as far as factors goes. And you could see what 3x and 15 have in common as far as factors go. But this is not so easy. How do you turn this trinomial back into this product of two binomials? Those two binomials there can be derived from this trinomial. How? Let's talk about how. So the way you factor this trinomial is actually something you've been practicing if you've been doing CP/M for a few years now. What am I talking about? Well, every time that you did one of these problems in your CP/M textbook, what you were doing was preparing for this moment. You were preparing to factor. The diamond problems would give you a number in this top part and a number in this bottom part, and they would say that the bottom number is well, let me just write out what it would be. You had x and y here, the bottom was x plus y, and the top was x times y. That was the pattern that you were always asked to follow. And you were given different combinations. Sometimes they gave you x and y, sometimes they gave you the xy and the x, sometimes they gave you the x plus y and the y, whatever. Now what we are doing is one of these diamond problems where you're given xy, the product, and x plus y, the sum. What am I talking about? Draw the little diamond. Feel free to draw yours more neatly than I drew mine. The xy, the product, is whatever the first term is in the trinomial times the last term in the trinomial. What is 6 times 12? 72. So you have 72, and you can add the x squared in there also. So 72x squared, but mostly focus on the 72. The bottom number, the sum, is the middle of the trinomial, which is just 17x, but focus on the 17. What two numbers must x and y be if they have to multiply to get 72 and add together to get 17? And hopefully you think about it, you can come up with 9 and 8, because 9 times 8 is 72, and 9 plus 8 is 17. Now let's look at the x's. Well, this says x, and this says x squared, so this has to be 9x and 8x, okay? 9x plus 8x is 17x, and 9x times 8x is 72x squared. Once you have these numbers, you're well on your way to being able to come up with this product right here, this expression right here, and then these two binomials. How do we do that? All you have to do is take your 9x and your 8x, and then take your first term and your last term and do the following. I'm going to draw a 2x2 box. I'm going to place my first term, which was 6x squared, in this part of the box, in this little window. I'm going to take my last term, which was 12, and put it in this part, in that window. And now I'm going to take the two things that I just came up with here, the 9x and the 8x, and I'm going to put them in the other two windows. It doesn't matter which one's which. So I put 9x in the upper right and 8x in the bottom left. You could have flip-flopped those. It doesn't matter. Now all you have to do is find out what each row and column have in common as far as factors go. So factor each row and each column. For example, 6x squared and 9x. What do they have in common? Well, 6 and 9 both divide by 3, and x squared and x both divide by x. So 6x squared and 9x both divide by 3x. I could do 3x times 2x to get 6x squared, and I could do 3x times 3 to get 9x. So they both divide by 3x. Then the next row, 8x and 12, both divide by 4, just 4, no x, because the 12 doesn't have an x. So it's 4. And everything's positive here, so I'm going to write plus in between them. So 3x plus 4. Now we do each column. What do 6x squared and 8x both divide by? They both divide by 2x. And what does 9x and 12 both divide by? They both divide by 3. And again, I put a plus in between them, and there it is. You can see your two binomials that we started with. 2x plus 3, there it says 2x plus 3, and 3x plus 4, 3x plus 4. Those are the two binomials. So what does that have to do with this very first problem that we have? This first thing doesn't look anything like those. Well, something funny might happen when you try to multiply two binomials together and you get a trinomial like we did. What if you happen to have a problem like this? Let's say I asked you to multiply 3x plus 4 times 3x minus 4. Those are two binomials, just like the other two binomials we had. So let's multiply them. Well, again, each term in the first binomial gets multiplied by each one in the second. So 3x times 3x is 9x squared. And then 3x times negative 4 is negative 12x. Now the next term in the first binomial times both terms in the other binomial. So 4 times 3x is positive 12x. So I write plus 12x. And then I get 4 times negative 4, which is negative 16. So I write minus 16. So this looks a little similar to the other polynomial that we had. This one up here, we had something x squared plus something x plus something x plus 12. On this one, we have something x squared and then minus something x plus something x and then minus. I mean, you could just say plus negative 12x. It kind of fits the same format. And just like before, we can combine the two middle terms together. And here we can combine the two middle terms together. But unlike the previous one, these two will cancel each other out. Negative 12x and positive 12x make 0. So when I combine those together, I get nothing. They're just gone. So the only thing that I have left is 9x squared and then minus 16. You might have noticed that we had up here 3x plus 4 and then 3x minus 4, and the only difference was this said plus and this said minus. Here, 9x squared is what 3x times 3x is, and 16 is what 4 times 4 is. This pattern is always going to exist. 9x squared is a perfect square. 16 is a perfect square, and we're subtracting them. When you subtract, that's called getting the difference. If you have the difference of two perfect squares, you will always be able to break them up into the square root of one plus the square root of the other times the square root of the first one minus the square root of the other. For example, if I said I had something like, let's start with something real easy, just x squared minus 9. X squared is a perfect square because I can get to it by doing x times x. And 9 is a perfect square because I can get it by doing 3 times 3. So I can break up x squared minus 9 into x plus 3 times x minus 3. Because the square root of x squared is x, and the square root of 9 is 3. So x plus 3, x minus 3. We could do that with any two perfect squares. Let's say I had 25x to the 4th minus 36y to the 8th. Well, both of these are perfect squares. 25x to the 4th is actually 5x squared times itself, because 5 times 5 is 25. And x squared times x squared is x to the 4th. And then plus 36y to the 8th would be 6y to the 4th if you took the square root of it. The square root of 36 is 6, and the square root of y to the 8th is y to the 4th. Y to the 4th times y to the 4th is y to the 8th. 6 times 6 is 36. So I can write 5x squared plus 6y to the 4th, and then 5x squared minus 6y to the 4th. So anytime you see two perfect squares being subtracted, you can break them up into the sum of the two square roots and the difference of the two square roots being multiplied by each other. So let's go ahead and do number 1 finally. Number 1 says to factor completely, and it says x to the 8th minus y to the 8th. And both of those are perfect squares. So let's go ahead and look at it. If we have x to the 8th and y to the 8th, what are the square roots of both those numbers? Well, the square root of x to the 8th is x to the 4th. So I can go ahead and write my x to the 8th minus y to the 8th like this. Sorry about that. Here we go. X to the 4th plus y to the fourth times x to the fourth minus y to the fourth. Those are the two binomials that we can break up x to the eighth minus y to the eighth into. But what do you know? X to the fourth minus y to the fourth, that's also the difference of two squares. So we can break that up. So we already have x to the fourth plus y to the fourth. We're just going to keep that for a moment. And now we're going to break up x to the fourth minus y to the fourth. X to the fourth, the square root of that is x squared. And the square root of y to the fourth is y squared. So x squared plus y squared times x squared minus y squared. So there's that. But what do you know? X squared minus y squared. Those are, again, two perfect squares. So let's bring down these other parentheses we had. We had x to the fourth plus y to the fourth times x squared plus y squared. And x squared minus y squared turns into x plus y times x minus y. So that is how you go ahead and you go through and you factor out some polynomials like those ones. Again, x to the eighth is a perfect square and y to the eighth is a perfect square, and we're subtracting them. So you break that up into two binomials, the sum of the square roots and the difference of the square roots. And since we ended up with the difference of two squares again, we could do that same process again, the sum of the two square roots of that and the difference of the two square roots. Then again, we had the difference of two squares, so we could again break it up into the sum of the square roots and the difference of the square roots. That gives us this whole thing, and that's what's written right here. It's not in the same order, but it doesn't matter. It's the same four binomials being multiplied, and when you multiply things, the order doesn't matter. All right, let's simplify this problem. We've got two fractions. We have 4xy over x plus 10y squared over y. The first thing you should look to do when you guys are adding fractions together is make common denominators. But something else that you should look to do when you are adding fractions is to simplify them first. Sometimes you can make the problem much easier on yourself when you do that. So let's go ahead and try and simplify both these fractions before we add them. We have 4xy over x and plus 10y squared over 5y. Well, what does 4xy mean? It means 4 times x times y, and that's over x, and 10y squared, I'm going to write 10 as, I'm going to write it as 2y times 5y. That's 10y squared, right? 2 times 5 is 10, y squared is y times y, and that's over 5y. Now you might see now why I did that. If 10y squared can be written as 2y times 5y, and this fraction is over 5y, that 5y divided by that 5y, they're just going to cancel each other out. Similarly, over here, this x and this x are going to cancel each other out. So what are my new fractions? I have 4y over just 1, because there's nothing down there, just imaginary times 1, plus just 2y over 1. So do I even need the over 1s anymore? Do I even need the fractions? No, it's just 4y plus 2y, which is 6y. Next up, which of the following expressions could be factored with whole numbers only using the difference of two squares? So the difference of two squares is what we talked about in the first problem. We did all this stuff. So which of these is the difference of two squares? Okay, is 4c squared minus 8d to the eighth the difference of two squares? No. 4c to the fourth is a perfect square, but 8d to the eighth power is not. See, the exponent of 8 can be broken into d to the fourth times d to the fourth, but the whole number 8 is not a perfect square. You need the whole number, the coefficient of that, to be a perfect square. That means 4, 16, 25, 36, 9, something like that. So this is not an option. What about this one? Are these two terms perfect squares? Yes. X to the fourth is x squared times x squared, and y squared is y times y, and we are subtracting. So this is the difference of two squares. Any even number exponent can be considered a perfect square for the variable it's being multiplied by. Any even number exponent. What about this bottom one? Is the coefficient a perfect square? Yes, it's 9, so that can be 3 times 3. Is the exponent even? Yes, it's a 2. m times m. So the square root of 9m squared is 3m, because 3m times 3m is 9m squared. What about the other term? 36n to the sixth. Again, perfect square coefficient, 36 is 6 times 6. N to the sixth, that's an even number exponent, so we can do n to the third times n to the third. So both of those are perfect squares. We are subtracting them. That is the difference of two squares. Keep going. This is a perfect square. 4a to the fourth is the square root. 8b to the fifth is the square root of that one. So this is also the difference of two squares. This one is not, because while r to the sixth could be r to the third times r to the third, s to the 25th, that's an odd number exponent, so that is not going to work. Finally, down here, y to the 12th, that's y to the 6th times y to the 6th, so that's a perfect square. 25z to the 9th, that is not a perfect square. 25 is 5 times 5, but z to the 9th, that doesn't work. That's an odd numbered exponent. Next problem. Factor the following expression completely. It's another difference of two squares. Let's go ahead and knock this one out. 64x to the sixth power. 64x to the sixth power. 64x to the sixth power minus x to the fourth power. So 64 is a perfect square. We get 8. X to the sixth, that's an even number exponent. So x to the third. And that's plus x squared, because x to the fourth can be x squared times x squared. So then I simplify that to 8x to the third plus x squared and 8x to the third minus x squared. Now, where does that say on any of these? Does it say that anywhere in here? And the answer is no, because we could have done something in the beginning before we did the difference of 2 squared that would have made this better. So if I'd asked you to simplify this problem and you went straight to this isn't wrong. This is, in fact, equal to what we had up here, but there's a better way to go about doing it, because what all of these have in there, they all have x's. So it goes back to the very first set of problems we did. I have binomials that I can factor something out of. Well, down here, I have binomials that I can factor something out of. I can factor x's out of both of them. So what I should have done is take the x's out in the very, very beginning. So let's go back and show you how that would work. 64x to the sixth minus x to the fourth. What do both of those terms divide by? The answer is x to the fourth. I can rewrite this as x to the fourth times 64x squared minus 1. Because x to the fourth times 1 is x to the fourth. And x to the fourth times 64x squared is 64x to the sixth. This is still the difference of two squares, because 1 is a perfect square. So now I can write it this way. X to the fourth, and then this becomes 8x, because 8x times 8x is 64x squared, and then plus 1 and 8x minus 1. So this is a much better version of this. Now I could get here from what I had up here. It's just a little bit trickier. Both of these can factor out an x squared. So it would be x squared times 8x plus 1. And then this would be times x squared times 8x minus 1. And then when I reorder these, x squared times x squared gives us x to the fourth. But it's usually easier if you remember to factor first. So x to the fourth times 8x plus 1 times 8x minus 1 is our answer. And that's what's written for D. All right, got a fresh piece of paper here. Let's do this problem. We got 81x to the 10th minus x to the 6th. This is a lot like the last problem. We can factor out x in this. We can factor out x to the 6th power. So x to the 6th power, if we factor that from 81x to the 10th, we still have the 81. And then we have x to the 4th, because x to the 6th times x to the 4th makes x to the 10th. And then we can subtract 1. Now, both of those are perfect squares. 81x to the 4th, that's a perfect square coefficient in 81. And we have an even number exponent with 4. So we have 81x to the 4th as a perfect square, and so is 1. So now we have the difference of two squares, and we can break it up. X to the 6th times 9x squared plus 1 times 9x squared minus 1. And hopefully you recognize that we again have the difference of two squares over here. 9x squared could be 3x times 3x, and 1 is again 1 times 1, so let's keep going. X to the 6th times 9x squared plus 1 times 3x plus 1 times 3x minus 1. There is your answer. So let's go ahead and take a look for it in our answer key, and this is it. It's the same stuff in a different order. We have x to the 6th, x to the 6th, 9x squared plus 1, 9x squared plus 1, 3x plus 1, 3x minus 1. It's all there. It's just in a different order, and that doesn't matter when you multiply. Next one, we again have the difference of two squares. They are just drilling this right now with simplify expressions as if it's the only thing that you'd ever have to do. That means it's important, so please know how to do this. Let's do another one. Let's keep practicing. 9x squared minus 64y squared. 9x squared minus 64y squared. What is the square root of 9x squared? It's 3x. So I have 3x plus the square root of 64y squared is 8y. So I have 3x plus 8y times 3x minus 8y. Is that one of our answers? There it is, 3x plus 8y times 3x minus 8y. And again, we have the difference of two squares, x to the 4th minus 256. Let's do it, x to the 4th minus 256. What is the square root of x to the 4th? X squared. What is the square root of 256? 16. So we have x squared plus 16 times x squared minus 16. So hopefully you can see where this is going already. We have x squared minus 16. That's another difference of two squares. So we have to keep going. Bring down our x squared plus 16. And now we break up this into x plus 4 times x minus 4. So there we go. X squared plus 16, x plus 4, x minus 4. Again, the order doesn't matter. It's just three things we're multiplying together. This binomial times this binomial times this binomial. The order of the binomials does not matter. Now this one's a little tricky. X minus the square root of 6x, in parentheses, that difference, squared. What is that going to be? Well, let's write it out. Let's go ahead and write out the whole thing without the exponent. If I have x minus the square root of 6x, and the x is under the square root symbol as well, and I have that squared, what does that look like if I write it out? It looks like x minus the square root of 6x times x minus the square root of 6x. So let's go ahead and multiply those together. I get x times x is x squared. I get x times the square root of 6x. I'm just going to write, oh, and it's negative. So I'm just going to write minus x root 6x, like that. Then I have the exact same two things being multiplied. Negative square root of 6x times x. So again, minus x times the square root of 6x. And then lastly, I have negative square root of 6x times itself. So it's going to be positive, and the square root of 6x times square root of 6x is 6x. So I have those four terms. You can think of the square root of 6x kind of like its own variable. Like if this said x times y minus x times y, it'd just be 2x times y. That's all it is. So you have x squared minus 2x root 6x plus 6x. And that's what your answer is, and that's what's written right here. Got another one. We've got a fraction as a coefficient in front of a trinomial, and it wants us to simplify it. Anytime that you have an entire thing like this, a good option is to just multiply everything out. So let's go ahead and do that. We have 3 over a. Let's try and make this a little bit easier to read. 3 over a times a to the third minus 4ab plus 7a cubed. So what we're doing for each one of these things is we're multiplying by 3 and dividing by a. That's what multiplying by 3 over a is. So each one of these, multiply by 3, divide by a. So 3 times a cubed is 3a cubed. but a cubed divided by a is a squared. If I had a cubed, let me just kind of do that off to the side so you can see why that would be true. If I had a cubed divided by a, well, a cubed could be written as a times a squared, so that would be a squared times a over a, and then the a's would cancel. So it would just be a squared. So that's what we have here. 3 times a cubed is 3a cubed, but a cubed divided by a is a squared. So the first thing we have here is 3a squared. Next, we have, again, times 3 divided by a. Positive times negative is negative, so we're subtracting. 3 times 4 is 12. But the a divided by a cancels out, so it's just 12b. And then lastly, 3 times 7 is 21. We're adding. And then a cubed divided by a again is a squared, so we have plus 21a squared. Now, what you could have done right in the beginning is said that 7a squared plus, or 7a cubed, I should say, plus 1a cubed is 8a cubed. And if you had done 3 times 8a cubed, you would have got 24, and then a cubed divided by a is a squared. And that's what we have right here. We have 3a squared plus 21a squared, which is 24a squared minus 12b. 24a squared minus 12b. Let's do another one. Simplify the following expression to answer with only positive exponents. Simplify the following only positive exponents. All right, so when we multiply these together, it's got parentheses. It doesn't really need it. Let's go ahead and write what each one of these things says. The first one says negative 6 x to the 5th, y to the 3rd. And then that's times a whole nother set of parentheses, which is 9 x to the power of negative 2, y to the 5th. So what is all that? Well, this is just negative 6 times x to the 5th times y cubed times 9 times x to the negative 2nd power times y to the 5th. It's just these 6 things all being multiplied together. So just multiply together the stuff that makes sense first. Let's just do negative 6 times 9, and then we'll do times x to the 5th times x to the negative 2nd power, and then we'll do times y to the 3rd times y to the 5th. Just multiply the coefficients, multiply the bases of x, multiply the bases of y, put them back together, and you're done. Negative 6 times 9 is negative 54. X to the 5th times x to the negative 2nd power is x to the 3rd, because 5 plus negative 2 is 3. 5 minus 2 is 3. And then y to the 3rd times y to the 5th is y to the 8th. That's it. Negative 54, x to the 3rd, y to the 8th. If you need more help, or if you run into one particular that's kind of tough, please let me know and I can look at the exact problem that you're having trouble with and I can help you out. Thank you.